Hey guys, this is Coach Scott again with some purple wave chemistry. Let's talk about exceptions to the octet rule. And again, there's not a lot of these, but there's some. So there's three types of ions or molecules that do not follow the octet rule. Number one are ions or molecules that are happy with less than an octet. Some of them are ions or molecules that will take an odd number of electrons. There's some weird ones out there. And then some of these can expand, all right, where there's more than 8 valence electrons. It's called an expanded octet. Okay, let's talk about some. So we've talked about these. Hydrogen, beryllium, and boron, they don't follow the octet rule. Hydrogen's happy with 2 electrons because it's only got the 1s orbital. And you could argue that helium is also doesn't follow the octet rule. Beryllium, it's happy, right? This is a metal and it will form molecular compounds more so than ionic compounds. It's true. All right. Even though it's a metal, it's going to form pretty much molecular compounds. So it only needs 4 electrons to be stable. Different. Boron, okay, it's sort of metallic. It also only needs 6 electrons to be stable. All right. So beryllium 4, boron 6. Now, there are some weird ones out there. All right, they're very rare, and you're probably not going to see them. Very unstable, very reactive, and these are there are ions and molecules that have an odd number of electrons. Look at nitrogen monoxide. Okay, so nitrogen has 5, oxygen has 6. 5 plus 6 is what? 11. So either one of these would be correct. Nitrogen may have one electron, and oxygen can also share it. So either one of those would be correct. You're not going to see these very often, though. Then the expanded octet. So these are sort of cool, right? So these are molecules that can form more than 8 electrons around the central atom. It's called an expanded octet. You'll see things like PCl5, right? Phosphorus pentachloride, right? So phosphorus has 10 electrons around it. Most of these have a d orbital that you can touch into, right? So they're always on at least the third energy level, and anything higher than that, they can expand their octet to 10 or 12 electrons, not just 8. So I'll practice one with you. Let's do sulfur 6. So we got sulfur there. Then we have our sulfur hexafluoride. So that means I've got 6 fluorines. Do that. Okay. And then sulfur has 6. Fluorine has 7. Oh, that's going to be a bugger. And but anyway, so there's sulfur, and there's 6 fluorines. So now, yeah, you start drawing this and turning this, right? And you do it. I'm just going to go to the answer key. This is what you're going to get. You've got sulfur with 6 valence electrons. It's got 12. It's happy. It's got an expanded octet. Xenon. Ooh, where is xenon? Xenon is on row 5, energy level 5, and it's a noble gas. It reacted, right? It forms a molecule called xenon tetrafluoride. And let's just look at that real quick. Whoa, all right, it's got an expanded octet. It's got 4, all right, 6, 8. Actually, 8 plus 2 plus 2 is 12. So it's got 12 valence electrons. It's happy. And it's a uh, noble gas. So noble gases can form compounds. It's the exception rather than the rule. And they've got to be pretty heavy. You know, you're talking krypton, argon, sometimes xenon, radon. They can do it. Now, BF3, boron, it's happy with 6 electrons, right? 6 valence electrons. That would be it. All right. And okay, so then we're going to get to our question. And next, we'll start going into the what we call the Vesper theory. We'll start talking about molecular geometry. That can be a little bit of fun. All right. And anyway, I'll make some more videos about that, and we'll have them out there. So thank you guys. Have a good evening. And this is Coach Scott, Purple Wave Chemistry, saying, "Hullabaloo, connect, connect."